This video presents HoloRadar, a new technology developed by Waves Lab at University of Pennsylvania. Imagine a robot navigating down a corridor. At first glance, the path ahead appears clear. But just around the corner, outside the robot's line of sight, a person is present. We introduce HoloRadar, a practical system that reconstructs both line-of-sight and non-line-of-sight 3D scenes using a single millimeter wave radar. It can even identify people hidden around corners. HoloRadar works by leveraging the fundamental property of radar signals. Since they have a much longer wavelength, common surfaces like walls behave specularly like mirrors. As a result, the signals bounce in predictable paths, and the returning RF echoes carry rich spatial information for non-line-of-sight 3D reconstruction. To extract these information, we first process the raw signals into a 3D RF heat map. We then design a multi-return RF imaging model to infer the hidden structures, giving us dense images at different signal bounces. However, each of the return comes from reflection off the geometry in the previous one, which shows a mirrored representation of the environment. To reconstruct the real 3D scene, we trace how the signal travels and where it hits. This iterative process helps us recover the real geometry. In this example, the robot is moving while the person remains stationary. On the right, we show our multi-return RF imaging results. Yellow boxes highlight the human in the non-line-of-sight image. Even though the person is hidden, our second and third bounce reflections successfully capture their presence. Here are the corresponding 3D reconstruction results. The non-line-of-sight geometry and the hidden person are clearly revealed. Now, we demonstrate the reversed case. The robot is stationary, and the person is moving. The motion is captured in the second and third bounce reflections. This dynamic behavior is also reflected in the reconstructed scene. We now present detailed comparisons with ground truth. On the left, there is no person in the scene. On the right, a person is present. Our system accurately captures both scenarios. Here is another example showing close alignment between our results and the ground truth. For more information, please visit our project website. Thank you for watching.